After receiving an email from somebody, I thought I can't not do the realistic 1008, which I suppose we could regard as a semi-toy hand portable. I've got the service manual in front of me. These are a single channel hand portable with a telescopic aerial. They work on channel 30. This is our test sample, which will service this test sample because it's a long time since we bought it. Let's see what it says on the service manual. Well, this works on its single channel channel 30, which is 27.89125, and the RF power output is 100 milliwatts. So that's what we want to know. That's what it is, 100 milliwatts. Now, if I zoom into that page of this service manual, you have a limit specification. So that means that 80 milliwatts is acceptable, and 120 milliwatts is also acceptable. So with that, we'll take it apart and we'll crack on. So we're now greeted with a printed circuit board, and I think we have to take some more screws out to strip it down further. There we are. Once we get to the component side of the board, we can see, unlike the really cheap sets, this does use some proper devices. It's got a LM38 6/4 watt audio IC for the receive audio, and notice it's a Samsung branded, and what is it? LM3361 is the FM IF subsystem with built-in squelch. So it does. The approach is good, although it's a cheap set. It's not. I don't know if any of them have seen the. I think there's the Humbrol one, which has about 5 transistors in it. And it's still FM, but they're really dire. But these are half decent as these cheap kind of sets go. And I think we had about a mile out of one of these back to our range test vehicles when we did those range tests at the time. Right, we'll hook it up to some test leads, because this is the trouble with these kind of sets. How to interface it with the test equipment. So I'll just get the soldering iron out and we'll get on with that. What I've done next is to remove L6. We're going to start with the transmitter. So I've removed L6. L6 on the circuit diagram is the antenna loading coil. So we need to connect our test instruments the transmitter side of the loading coil, otherwise we'll be having a high SWR. So we need to be connecting straight to that switch there, or that side of the coil. So I've taken the coil out, so there's nothing in circuit. So we'll proceed a bit further. Right folks, we've got it connected up to the test equipment. I'm doing it with a PP3 battery rather than off the bench power supply. It's a brand new alkaline PP3 battery, and I made up a little sheet of adjustments here. Let's just zoom out. I daren't move the radio, I think we'll be moving the camera. So what I've done is to solder a wire where L6 input is, the loading coil, and then I've soldered a little wire onto the earth of that. Just widen that again, of that can there, and that's how I'm picking up the antenna into the test equipment. So we're going to start with the crystal frequency, and the transmit crystal is that one there. In fact, I'd better point it out with the yellow tool, you might be able to see it better. Is that one there, and I reckon that I've gone and lost my plot now. It looks to me like it's the frequency adjust, and T5 looks to me like the first transmit adjustment, and then we've got 3 cores in coils there, L5, L4 and L3 from what I can make out on the circuit diagram. So that should be T5. So theoretically that should be T4. So we'll go for that. We'll see what happens. We're going to transmit. I should have 27.89125 with 27.89115, which is well within tolerance. Does this adjust it? We'll find out. It does indeed. So we need to go down to bring the frequency up. And that looks to be as high as we're going to get it. For, well, we want maximum oscillation, to be honest. And that's 89111, so that'll do nicely. So it isn't frequency adjust really, it's maximum oscillation. Now at the moment this radio is, I'll have to read off this scale because it's a bit, 100 milliwatts. It's actually doing 55 milliwatts. So we'll move on now. We've gone from that coil, we'll go to this coil. That's actually adjusting the frequency. So there you are. Wasn't quite how I thought. So 891. Sometimes these cheap sets aren't adjustable. But this is. So we've got maximum oscillation, which I'll now backtrack on. Sometimes these are interactive. There we go. And it's spot on frequency as well. So, just point that back out again. Maximum crystal oscillation with that one on transmit, and the frequency just with T4 there. So we'll just now move up to L3. Drops tool in radio. And that is now tuned up on transmit with the 3 coils there, and it's certainly doing the 80 milliwatts plus that it's supposed to. Now we'll do the deviation. Now it's a condenser microphone which is just there. This is going to be novel. I'm going to have to whistle into that somehow. We've got the other cameras back. I'll just switch that in. I'm going to have to set the frequencies because we normally work on channel 20. This is channel 30, and that's giving us, if you can see that, that is giving us 2.5 deviation. So if it needed adjusting, and it doesn't on this one, then it's preset RV1, which is just there. So that's it. That concludes the transmit. We're going to do the receiver, then I'm going to put it back together, and when we'll tune the telescopic aerial, so we're kind of going to go back to transmit. So I'm going to do another video for receive, and at the end of that it will include how to set up the telescopic aerials loading coil, which is the L6 which we've removed. So see you on the receive side of the video.